Hi everyone, this is changAI, an AI assistant for ERPNext that lets you ask business questions in simple language and get instant accurate answers. No reports, no technical queries, just ask and get insights. Let's see it in action. I'm going to ask which customers give more sales this year. Let's see what model reference. Yes, model gave the bigger has given the most sales this year with a total of a value given. Now we can see the debug tab. In debug tab, we store the debugging details. So we can see the SQL query and ORM query here. The model gave the SQL query as this. You can see it. Now let's go to chat tab and ask the next question. I'm going to ask last month total invoice amount, how much we did. The total invoice amount last month was this. Okay. Now we can ask the next question. I'm going to ask pending payments, which customers not paid still. In debug tab, we can see the results, both SQL and the ORM query. Okay, fine. Now we got the pending payments, which customers not paid still. Here are the pending payments listed. There are many pending payments. Now let's go and ask for the next question. Which item stock going low now? Let's see what model gave. In pending payments, we got the SQL query as this, partially paid and overdue as the status filter. Also in the Frappe ORM query, we are filtering by that. Now we got this as a model generated an invalid query. Actually here the model gave the accurate SQL query, you can see that. But we failed in the validation part. We will update that in the coming versions. We will solve that issue. For majority of the questions, we are getting the right results. Now let's ask the next question. Show items, no stock or zero quantity. Now we got here are the items with a zero stock. For show items with no stock, we got this as item name and the warehouses listed. Now I'm going to ask supply pending bills not cleared. Here are the supply pending bills that are not yet cleared. You can check the debug tab. Select name from tab purchase invoice as T1 where T1.status is not equal to paid. Next question, production not completed, which work order still open. So here also we failed in the validation part, but we will solve it in the coming versions. Now let's ask the next question. Top selling items last 3 months. Model is in the thinking state. It'll take a few seconds to get a response. Okay, now we have a support tab. In support tab, you can type your support issues. You can post there, which can create ticket or get ticket details like that. But we are working on it. It's currently in the inactive state. Now the top selling item last 3 months is item 1 with a total amount of 291,201. Which customer have highest outstanding now? Let's see what model gives. The customer with highest outstanding amount is Deepika with an outstanding amount of 158,455,260,000. Today's sales invoice, today's sales, how much we did? I think it would be null as I didn't add any sales invoices today. Maybe I can check that. So today the total sales amount is null. Now let's go and ask for the next question. For that, in debug tab, we can check if that SQL query is right or not. We have the SQL and we have the ORM. Frappe get value, sales invoice, filters, posting date is equal to today, and select sum grand total where posting date is equal to current date, filtering by today. Now let's ask which invoice is still not paid fully. So these are the invoices that are not currently paid, not fully paid. Now let's check the debug tab. Frappe get all sales invoice status in partially paid, unpaid, and overdue. Fields name we are getting by name. Select name from tab sales invoice, status partially paid, status unpaid, and status overdue. Because here we are using we are passing the options, the exact options in the status field. You can see that there. Draft, return, credit note, issued, submitted, paid, partially paid, unpaid, and discounted. So that's why we are getting that accurate option value in our SQL query. Now let's go and ask the next question. Which item stock finished in warehouse? So these are the items that are stocked in warehouse. Now in SQL query, we can check and validate if the query is right or wrong. This is a Frappe ORM query. Filtering by project quantity less than or equal to 0. Getting the item code. And asking show slow moving items last 6 months. There are no slow moving items to display in the last 6 months. So which warehouse have more stock now? Can check the debug tab to make sure everything goes well. So the warehouse with the most stock is work in progress CD with the 268 items. Can see the debug tab. Select tab bin dot warehouse where actual quantity as total stock from tab bin, group by tab bin warehouse, order by total stock. Now let's ask which supply we purchase more this year. I could not find any purchase data for this year. That's the result. So we can go and ask the next question. So purchase invoice filtering by posting date between the first day of this year and the last day of this year, getting the fields, supplier and grand total. In SQL also, we are getting it for the current year. Purchase invoice as name dot supplier where posting date is equal to year of current date, group by supplier name. Now let's ask the next question. Pending purchase orders not received yet. So these are the pending purchase orders, but we can make sure whether these are the correct ones or not by going to purchase orders stock type. So we can see the ID, purchase order 0004, 1, 2, 3, 4 and 11. So yeah, these are the right purchase orders that are not received yet. Now, which item production delayed or not started? No items are delayed or not started. You can check the debug tab to make sure the SQL is right. Select name from tab work order where status is equal to not started or status equal to in process. For ORM also the same thing. Now, how much stock we have for tops in warehouse? So there is no stock information available for tops in the warehouse. So let's go and create one for tops and see whether model can return the accurate results. So tops target warehouse as main warehouse and item code as item code is also tops, quantity 100. I'm going to now let's save, submit and check again. Same question we are going to ask again and we can see whether model can give the right one. How much stock we have for tops in there? Okay, fine. We got it. We have 100 stock for tops. You can see we provide a quantity of 100 for tops. We got that accurate result here. Okay, now let's go and ask the next question. Okay, so here I'm going to ask show customer Amran. Let's ask something related to the master data entity values. Let's see if the model can return the accurate result of the customer Amran. Similarly, in the case of tops also, we passed the tops as an item value, right? So that's why we got the accurate result. That's why we are passing a master data here. Otherwise, we will get some assumed things which does not exist in our records and we will get an error like item does not exist or customer does not exist. Amran Yusuf is an individual customer created on the state. Now we can check the debug tab. You can see we already provided the name as Amran, but we got it here as Amran Yusuf, the full name. The model returned the actual record of that Amran Yusuf. So even if the question is not that, if we didn't provided the actual item name or actual customer name, the model can get the most matching results for you. Similarly, for the case of tops also, we are providing entity cards that's actually retrieving from the master data. Now that's why we are passing a master data, and that's why we are. So only then we can get the actual master records that exist in our DB and get the exact details.
In this video, we will explain how you can set up your changAI, and we will explain how to set up your changAI settings software and this everything inside this. But before going to that technical side, I will give a small idea regarding the core logic. So when a user types a question, any message or something like that, first of all, the first stage is retrieval stage. We have a retrieval engine that is a schema retrieval. I think I already explained in the previous video. If you have any doubts, you can watch that. And this retrieval retrieve the schema. That means the required tables, fields, and master records that are needed to generate an SQL for your related query. If this is the question, we have to write an SQL query in the DB and we have to get the data from that. This is how it happens manually. So with the help of this changAI, we can just ask that natural query in our own language, such that the model can return the relevant data as per your records based on what is inside in your records. So for that, the first stage is retrieval. Retrieval means to retrieve the relevant meta from your DB or from your schema. So we have that happening in two different stages or two different methods. One is a local deployment method and the other one is a remote deployment method. In local deployment method, we recommend this local deployment method as it is more secure than remote deployment method. But it's based on your needs. If you have any limited server resources or if you want high scale needs, we can offload the task to cloud providers. And we have already shown the example of Replicate as a remote server in our previous videos. Now coming to the local deployment setup. In local deployment setup, we want to make sure that we have to download the model locally such that the model would stay in your own local server or in your own infrastructure. It won't go outside. So you are safe. And your DB, your schema, everything would be in your local server itself. It won't go outside. So that means you have a privacy there. Now, with that particular model, but make sure in case of local deployment, in this case, you need to download your model by clicking on this download embedding model button in the settings document. But before moving to that technical side, let me complete this. So this model, which you already downloaded, will give you the fields and will give you the tables and master records needed to generate the SQL. Once you get that, you have to write an SQL, right? We need to write a proper SQL to run that SQL. Once we run that SQL, only then we can get the data from our DB. So for that, we are using Gemini. Gemini is good at reasoning, and it is also very good to give you a proper SQL query and based on what we provide as a schema context. So once we get these things, these schema details, we pass it to Gemini. Gemini writes an accurate SQL query based on what it get. That means what schema context to be provided. So once Gemini get that, it can give you a proper accurate SQL query. In case of Google Gemini, you can choose the free version API of Google Gemini, or you can use the paid version Enterprise Vertex AI setup. Gemini is what transform your question like show me pending shipments into an executable SQL query. And then you can execute that SQL query and finally show the data to the user. Here we handle the permission setup. We don't directly execute the SQL query. We are handling the user permissions. Once we get the SQL, then based on that only we will execute the SQL. Now, I think you got an idea regarding the local deployment part. So in the settings doc type, we have the Gemini, the paid tier, and also we have the free tier part, which will be explained by my colleague after this. Now coming to the remote deployment setup. In remote deployment setup, you don't need to go and click on this button because this is only meant for the local thing. You just need to make sure to check the remote check mark in the settings doc type, and yeah, it will be explained after this, but this in remote deployment part, you will get the tables and master data, everything, the stage, everything would be same. But only thing is that you have to pass your schema and your tables, fields, schema, and your master records as a FIAS vector store into this remote server. We store that in a form of a vector format in a remote server. So it's not that secure like how it is for local deployment. And in remote server, we already have a model, so retrieval, the same model we used in the local deployment and which is already deployed remotely on the remote server. In our case, we used replicate. We already shown how to set up your replicate account, how to test from a replicate, how to use the replicate APIs in our previous videos. If you have any doubts regarding that, you can watch that videos. Now, once you get the tables, fields, and master data from this remote server, we write the SQL. Here we use Qwen3 model for writing the SQL, and this model is also deployed in the remote server. So once we get the schema and the master data, we pass to this model, which is deployed in the remote server, and finally we get the SQL. Same stage, but only difference is it's local and the other one is a remote. And when we get this SQL, we check the permissions and finally we execute it and then show the data to the user. So this is how it is taking place, the local deployment and remote deployment. And we recommend you to test with the local deployment as it's more secure than the remote deployment. Now I will pass this video to my colleague. She will explain how you can set up your changAI settings doc type.
So here we can see 4 tabs like detail tab, remote server tab, support and training tab. And in detail tab, we can see a remote check. There are local deployment setup and remote deployment setup. If it is local, we need to uncheck this remote. In local setup, schema retrieval is complete locally. Then we need to pass Hugging Face models and dataset repos. These are the IDs for embedder repo and dataset repo. Then we need to pass Qwen3 4B instruct. Then we need to make sure that LLM is Gemini. Actually, it is used for SQL generation. When using Gemini, make sure you have Gemini authentication, either paid tier or free tier. If it is based on your usage. If it is free tier, then paste the API key here. If we didn't paste this API key here, then you will get an error message. I will show that. So you will get an error message like this. So you need to paste API key. You will get API Gemini API key from aistudio.google.com. Then click this create API key. Then copy this and paste here. After saving, just then you will get this reply. So if it is paid tier, you need to pass all this like Gemini location, Gemini project ID, service account credential. If any of this is missing, you will get this kind of error message. I will show that too. Then you will get the reply. After that, you need to download this download embedding model, or else you will get an error like this. I will show that too. So without downloading this embedding model, you will get an error like this. So let's check after downloading this embedding model. Then you will get the correct answer. And make sure to check retain memory and select retriever structure as multi-line. Then let's move to remote server. Actually, it shows detail regarding the remote replicate. Here we are using applicate as remote server. We are explained it in our previous videos. So make sure you have replicate account and replicate API token. So paste your replicate API token here. Then model deploy version ID from multiple model like LLM version ID, schema retriever version ID, and entity retriever version ID. If we are going to test your model remotely, then paste replicate prediction URL and replicate deploy URL. Make sure you have OpenAI API key and Cloud API key. We are using OpenAI API key for generating training data and Cloud API key for generating validation data. If you are going to test your model remotely, make sure you are checking this deploy button here. So let's move to support tab. Actually, it is in working process. Our plan is to handle the support issue with chatbot so that user can post their issue in support tab in chat UI. So this is support tab in our chat UI. Next, let's move to training. Actually, training is mainly used for automating training data creation, also automate master data updation and schema file updation. In order to train the schema retrieval model, we need to have proper training data. So you can mention here training record size and click this create training button. But before that, we need to add modules and description. I'll show that. This is the this here we need to add modules and description. Trained model is focused on ERPNext modules. So test with ERPNext queries. To create training data, you need to add row in this table. For different modules, you need to cover for preparing training data, and same time you need to give proper description regarding that modules, like what that module covers, why we are using that modules. Such a small description also in description column. So let's do that. Once you provide multiple modules, you can select the modules for which you want to generate training data by checking that specified modules in the table, and provide training record size. If you're providing 100 as record size, then 100 training data will be generated from each modules. So here I am clicking 2, then click create training data button. After creating this train data, next one is update master file and update schema file. This button is specifically meant for updating master data. It is the master record which covering master tables. When we click on this update master data file, it will automatically update the master data based on the last modified date. Then next one is update schema file. It is used for updating schema which is stored the table and field which will also update based on last modification.
This is what setting doc type is used for. Now you can go for testing chat UI. Now you get the answer. So there is three tab in chat UI. First one is chat, then debug and support. Debug is meant for developers to check debug data in between different stages. So that's all about this Shanghai settings. If you have any doubt regarding this, please do contact us on support at erpgulf.com or cladion.com. Thank you.
Hi everyone, welcome. In this video, I will explain how can you improve your model. So in this video, I will explain how to train, how to create your training data, how to test your data, how to create the test data, how to compare the models and how to push the model. But before going to the technical side, I just wanted to give you a small overview. I just wanted to give a small overview of why we have to train, why we need to test and uh, why we have to do all these things. So before going to that, I hope you know what is a schema retrieval model. Schema retrieval model, for those who don't know that, let me give a small overview. Schema retrieval model is an embedding model. Embedding model can can search a document and can return the similar things out. Before that, let me show you one few example. If a user types a question like choose the vehicles, and four options, this is a document. Let's see if this is a document. This embedding model, the embedding model we are using is modern but embed based model. You can go and check Hugging Face. In the Hugging Face models repo, you can go and search for modern but embed based model. You can get it from there. Modern but embed based model. So Nomic AI is the provider. This is the model we are using for schema retrieval. But this model is not at all capable to handle ERP queries. Suppose if a user types a ERPNext based user query, like any ERP query, the model was not that good at the response, but training and improving makes the difference on such domain specific areas like ERPNext and other modules. So this model was already capable to give response for the general query matching. So when a user asks choose the vehicles, the model can understand the difference between a vehicle and an animal. So such data was already used for training this modern but embedded based model, because it's already know such things which it trained on, but it does not know the things it is not trained on. So for custom domain specific areas like ERPNext or any specific modules, you have to make sure you are teaching the model. Teaching model on the data to which it has to give response, then only it can give the right response. Like how we teach a student, it's the same thing. The student can make mistakes. Okay, same thing here happens. If we wanted the model to work on a custom table or a custom fields or custom modules, we have to make sure we are training or teaching the model on that custom data. How we can train the model on custom data and how the model learns that. But still, after training, you cannot expect after a single set of training the model will fully be capable to return for any related queries of that specific custom model, because it's not possible. The model learns step by step. It learns from mistakes. How normally humans learn, the same thing happens here. Model learns step by step. It can make mistake. So this model we used as a base model. We trained that model on a ERPNext specific queries. I shown the data set, right? So that similar data set we used for training. That same type of data we used for training this base model, and after training it started understanding ERP domains, ERP specific areas, and it started matching it was capable to match the some type of queries to the right things, but still there are wrong areas. We cannot be 100% perfect, right? So still it may fail in some areas, but we will catch them and correct them. Like that it happens. So let's see, before training, if we are using this base model, if we test this model on specific data, the model will fail. As it already has a similar names, there is a chance that it can return such similar things. But in case for those type of queries where user does not mention clearly the exact context in the question, the model failed to give the right response. Okay. So after training on it on a ERP specific domain, it was able to match the right query to the right data. Okay. Before training, it was not able to catch the content of the question and map to the right tables or fields. But after training, it was able to understand the relationship between the certain tables and certain queries, and it was able to work on some new data also. The questions it never seen. It was able to match the context and map them to the correct ones. But still there are failures. So that's what improving and training does. I hope you understood why we are doing training, why we are teaching the model. So that's it about base model. And now the base model fine-tuned on a ERP specific model, and it's stored on the side inside this repo hiring Mansur changAI Nomike. So this repo is the same base model, modern button but base model, but this trained on a large ERPNext domain specific data. This model repo is the fine-tuned version of our base repo that I've shown just before. The fine-tuned version of this model repo. This model repo was not that good at ERPNext specific domain, but this model is good at ERPNext domain because it's now trained and learned well on some ERPNext stories. So now moving to the the schema retrieval model, we called it schema retrieval because in our case we used for retrieving the schema and retrieving for master data. So this model will check our schema document, search the schema document. If we provide a query, it tries to match that specific query to the exact tables and fields inside this document. Okay. And coming to this part, whenever a user mentions a customer name or any item name or master values inside the user question, we need to make sure we are passing a master document. Master document is a document which will stores the master tables records. So if the user does not, in most cases user does not mention the exact name of the item because they don't remember the exact name or exact spelling or nothing like that. So we have to pass the master data. So this model will check the master records and it can return the most matching records from the master data. So we have to keep on updating the master records to get the latest updates of the master data. So I hope you got a basic overview of model training, why we have to do model training, what is a model, what is an embedding model, what is its purpose, what its importance. Importance is very huge. This model is the one which is making the difference in response. If the model's response is bad, then we cannot be, then the final SQL query would be bad or would not be accurate. Why? Because this model will return the right tables and fields from your own schema. If that went wrong, then we cannot be sure about the SQL. Then following SQL would also be wrong. So that's an important part. Make sure you are teaching and updating your model well on your data. Now let me explain the training code. Now we already explained what is the importance of a model, right? Now the next part is training data set creation. Because before going to the training technical code, I just wanted to take you to how we can prepare the training data. Training data is important part. Let's go to changAI settings doc type. Inside changAI settings, you can see there are multiple tabs. We already explained these in our setup video. You can watch that if you have any doubts regarding how to set up changAI settings. So this is our schema retrieval model. When we download this, it will download the latest trained version of our schema retrieval model. So inside the training tab, you have already seen this model and description where you can mention the modules for which you wanted to create the training data. So when you mention 400, for the selected modules, it will generate both the training and the testing data, not just the train data, also the test data. When you click on this button, it will generate the train data. Now the train data will be get stored inside the file doc type, inside the train data folder in the home folder. Inside train data, this is batch 4. This is the latest version. I mean, this is the folder where we store the training data that is used for the latest training setup. This is the first phase training data, second phase training data, third phase training data, and currently we are in the fourth state trainings data, fourth state of training, and this is the fourth state training data folder. Here you can see module wise we have created each and every training data. Let me show you a small format of the training data, how it looks. So we have an anchor, a unique ID, and also we have the right positives. Positives in the sense the tables and fields that is required to generate an SQL query for a respective anchor. These are the user queries. So we also provide description for tables and fields. The reason why we are providing description, because we provide context to the model. Teaching the model with the context can give you a better output. So that's why we provide description for both tables and fields also. So you can see the variety of user queries. List all goods received for purchase order. Find all items that have been received. Let's see a description example for purchase receipt. You can see. Or let's see another purchase order item. Individual item lines on a purchase order. Sales order, manage customer orders. Purchase order item, details of individual items on POs. Records of incoming goods, purchase receipt, like that. Now, similarly, we also have a test data. By clicking on the changAI settings train data button, it will generate both the training data and the test data for the selected modules in the table. And the test data will get stored inside this validation data folder. Inside the batch 3, this consists of our latest test data files. Same format except in same format as that of the train data, except that we does not provide descriptions for tables and fields. Now let's move to the code part. Now we have already generated our training data and test data. Now we need to make sure we log to a Frappe. So before that, let me introduce you Collab. Collab is a environment, cloud environment where you can train your models, and this Collab provides you different GPU resources. The reason why we are using Collab, because of the limited GPU, we are using Collab for training our models because it provides multiple GPU resources. Let me show you a few resources. Can see multiple GPUs are there. Currently we are using A100 GPU, and you are using a Collab Pro Plus subscription. So now here this Frappe session code, you have to make sure you have logged to your Frappe session, and after logging in, we are fetching and merging all the training files into single file, because we wanted to make sure there are no duplicates, and we wanted to merge every modules as a single file for training. We also merge all the test files from the validation data folder into a single file, and we make sure we have duplicated the files to make sure there are no duplicates before training, and they are saved into respective JSON files. You can see the result of this. Now let's move to the training code. We have many imports. Random imports are there, and sentence transformer is one of the important import, because this is a library, sentence transformers library, which is specifically meant for training the embedding models like our modern BERT embed based model. Losses, it's also another important part, because multiple negative ranking loss is a loss function which decide and which will teach the model which is right and which is wrong. And training arguments, the arguments and parameters required for training the model. Then trainer, and then evaluation. Evaluation means from the training data, we have to evaluate the model after training. After every training steps, we need to make sure we are evaluating and confirming whether the model is giving right or wrong. That's what evaluation meant to be. So that's what this part does. So let's go to the code part, main code. We pass a model name. Here I am passing my model repo. latest fine-tuned model repo. But in your case, make sure you're passing this model repo because this is the latest ERPNext trained version of the model. By passing it here, you can pass your training merged file we just done before, not the test but the train, and output directory. You can pass a drive folder of yours in order to save your model model files. Don't push directly to Hugging Face after training. You need to make sure you are comparing and checking if the model improved or not. Only if improved, you can push. I will come to that part. We provide a batch size. We send by batches for training. In a single batch, there would be 32 records. Epochs is the number of cycles, 5 cycles of the entire training data. Now, we load the training data. We create an evaluation data set from the training data itself for validation purpose. And we load the remaining training data for training purpose, and we load the validation data. So then we initialize the training arguments. We pass the output directory to which the file gets stored, epochs, batch size, learning rate, and we save by epochs. That means for every checkpoints, we will save that to our drive in order to find the better checkpoint. Now we initialize the trainer model. We pass a model, we pass the training arguments, we pass our training data, we pass the loss, and we pass our evaluator. Evaluator, we just created it here by passing embedding similarity evaluator. This is specifically meant for creating the evaluator using our evaluation data set. From where we made the evaluation data, from the training data sets itself, we generated the evaluation data set, but only some few records or samples from the training data is considered as the evaluation data. I hope you are clear up to this. Now, when we run this, we start training. So, the main important thing is loss function. I will explain what is a loss function. Loss function is the one which will train the model. Which will train the model which is right and which is wrong. Suppose you can see if this is an anchor, user query. If this is a negative, before loss function teaching the model which is right and wrong, it was like this. Negative was much closer to the user question and positive was much far away from the user question. Negative and positive, I hope you understood what is negative and positive in this case. Negative in the sense the wrong tables and fields that are not required to generate at scale, but positives are the right things. Okay. After loss function learning, after loss function teaches, it become like this. Anger and negative become too far. Distance would be high. Distance between anger and positive becomes much closer. So, with the help of loss function, the similarity between the anger, that the user question, and the correct positive would be high. Similarity score would be high. But their distance would be very low and their similarity would be very high. Similarity score between the user query and the positive would be high. Similarity score between the user query and the wrong positive would be low. Okay. If a user types of how many customers, the right positives are customer name and tab customer. The wrong positives are stable invoice. So loss function will help the model to make these things closer and to make these things further away. Okay. Like this. If P2, P3 are not required for Q1, then loss function will put P2, P3 away from Q1, put P1 closer to Q1. If queried Q2, if P1 and P3 are not right, they will be kept away, and P2, if this is right, it would be kept closer to Q2. This is what loss function does. Now, finally, after training, we will see an output like this. Epochs, 5 epochs, and the training loss. Make sure your training loss is gradually increasing through increasing steps, because if it is increasing train loss instead of decreasing train loss, that means your model is overfitting. That means it's trying to memorize instead of generalizing. So make sure your training doses keep on decreasing over the increasing epoch. That's the result of a good training code. And your final model would be saved to this your specific output directory. Now the next step is, once we have completed our training with our training data set, now we already completed how to create training data. Now we already covered how to create your training data, how to create your test data, and how to train your model. Now the fourth step is compare the models and then push the model. Comparing model means, as I already said, we already created a test data from our settings page along with the training data. Do you remember? Then that test data is used for comparison. So before going to the comparison code, make sure you installed your necessary libraries that's required for testing. So inside this testing code, we compare the current trained version of the model, the current latest model, and the previous version before training. I just passed here 3 models. Don't bother about that. I just passed the pre version also just for the comparison. But you just only need to require to pass the current version and the previous version of the model. If you are making this comparison for the first, then you can pass the this model repo as the old version, and and this can be your trained version models directory file. But make sure for each of this model and for each of the models you have to pass your FIAS vector store. FIAS vector store, how to generate the FIAS vector store, I will explain. We have a code for that. For each model, you need to generate the FIAS vector store, and you have to make sure you are passing the FIAS vector store along with the model. Then when you run this, you will get an output which look like this. So far, we got better accuracy for the latest version of the model with a 1.5 or something a percentage improvement. So best model would be stored. Along with this, the best model's failure predictions, failed predictions would also get stored to this particular file. Now, which would be required for the coming stages of training data creation to focus on the mistakes, which can make the model learn from the mistakes. So now let's after we store it, we have to upload those wrong predictions into Frappe file doc type. So I run this code to push the files from this folder, which currently have the wrong predictions, into the test results folder in our file doc type. In a file doc type, we also have a test results folder, which will store the wrong predictions of the models module wise. So each of this module wise will have the wrong predictions given by the model. That's required for the next stages of training data creation. So this code will upload each and every module wise wrong predictions of the best model. Okay, so now once we compared, if we are getting an output like this, that means if the latest trained version of the model is having the better accuracy out of the previous model and the previous model, then that means your model improved. Then you can push your model to Hugging Face. Now, how you can push your model to Hugging Face? That's our next step, right? How to push your model to Hugging Face. So, in order to push your model to Hugging Face, before running this code, make sure you already logged into Hugging Face. Logging to Hugging Face needs to run this code. But before logging to Hugging Face, make sure you already created a Hugging Face account by going to Hugging Face or create an account, and you generate an access token from here. Then once you generated access token from the login code, you will get a pop-up, paste your access token, and now you have authenticated Hugging Face account. Then you can go for the uploading to Hugging Face step. So for uploading Hugging Face step, you have to pass the repo of your best model here, and this will remove some bad tokenizer class, and then you can mention your repo ID. Don't mention this as the repo ID, mention your own repo. You just have to go to this. Once you created your account and access token, new model, create a repo, let it be test 5, provide a license, can make it public or private, can make it private, and create model. Now this repo, copy it and paste it here. Okay, now you created your repo and can provide a commit message, run this and push. Now it would successfully push your model to a Hugging Face. Okay, I think the overall technical improving of model explained now, but we need to know how we can create the FIAS vectors too, how to generate the FIAS vectors too, because we don't directly pass the schema as a text to the model. We convert it into a vector format. I already explained these things very widely in my previous videos. If you have not watched them, please do watch and then watch this. So we convert our schemas into a vector format, and that vectors would be passed to the model. From that vectors, model will give you the right tables and right fields, all of that. So how can you convert your schema into a FIAS vector store? That's what I'm going to explain next. So before explaining how to generate the FIAS vector store, let me give you, we have a multi-line retrieval structure. That means normally we used to have a single line retrieval approach, in which we will if this is a model, we pass the full schema to this model. Okay, full schema in the sense both tables and fields, everything in one file. Okay, the schema, full table and fields. But at that time, model has to look on a big data, right? Because there is a huge context or a huge document on which the model has to search for. So from, we got a proper accuracy, but another approach where we used, instead of the single line of approach, we used another approach, which is if this is the model, first pass only tables to models. Tables, only a document that consists of only table names like employee, customer sales invoice, like that. We pass this to the model. Okay. Now model will check this table, and also we pass the user query. We directly don't pass the tables document. We convert it to FIAS vector store, and we pass that FIAS vector store to model. Okay. So also we pass the user query. Q be the query. Now model will predict the required tables from this FIAS vector store. Okay, we pass the table FVS, table only FVS. We pass the table only FVS to this model. Also we pass the user query. Now model will have to check on this table FVS, and it will give the exact, or it will give the most matching top 20 tables. Out of this, it should include the exact tables that is needed for that SQL. Now from this top tables, we will select only the tables that is required for the SQL generation. How? So for that, we call Gemini here. We call Gemini, ask Gemini to filter only the required tables out of this top 20 tables for this specific user query. So Gemini will give us the required tables out of that. Gemini will give us the exact tables out of this top 20 tables that is required to answer this query. Now we have reduced the top 20 tables to the exact number of tables. Suppose if it's a one table is the answer. Example employee, for how many employees we have. Suppose if that's a query, we pass the full table appears to model. From that model predict table employee, table client, or table customer, like that. We take the 20 tables because for some other queries the model used to give the tables, the correct tables in the top 20 or top 25, like that. So we just round it to top 20. Now we pass that to Gemini. Gemini will choose the exact tables out of this. So it choose the exact table, and the next step is we will generate, we will extract this table's full schema. That means this particular table's fields, every fields from the full schema file. Now we will have the schema for table 1. Schema for table 1. Full schema only for table 1. We take only the table 1's full schema. Now instead of passing the entire table schema, we are only passing one table's full schema. Now we again pass this to the model, and also we pass the user query. So model has to get us the exact fields that is needed to generate the SQL query for the specific question. So model will check that full schema for this particular table 1, and it will retrieve the fields required. Now we got the fields and tables that is required to generate the SQL query. Okay, so the reason why we used multi-retrieval approach, the reason is that in a single retrieval approach, we need to pass the full schema to the model. We convert that full schema, entire tables, entire fields in the DB into files vector store, and then we pass directly to the model. But that was not a very good approach, because that was an approach, but later we came to know about this multi-retrieval approach. We just made a test. At that time we got that when we first of all we pass the table only FES, at that time we reduce the size of the context to search for. So model has to search only a limited, a small size of the document. At that time model can give more accurate results. As long at that time model can give a proper accurate tables from this listed tables list, and we pass that to Gemini will choose the exact tables required from this. Then we take out that table only, that 1 or 2 or 3 tables based on how much it required. Then we extract, or then we generate the schema, full schema for that specific table. It's FES. We pass it to model. We ask again model to retrieve the relevant things needed for this specific query, and using this schema only, at that time model can retrieve only the exact fields out of it. So another advantage of using this approach is for some doc types. Many doc types may share common fields, right? When a user question is asking for posting date, many doc types can have posting date as a field. Okay, so model get confused sometimes. Model get confused which all doc types and like that. So that in order to reduce that issues, we are using this approach. For this, we got much better accuracy than that of the single retrieval approach. So this is the method. And after all, we take the top 40 fields from this model, and then we pass again to Gemini and ask Gemini to filter only the required fields from that. Then we pass it to Gemini for generating the SQL. This is the actual pipeline. So why did I explain this is because in order to generate the FES, currently the first stage we will be generating FES for the table. I explain here we create a table FES, we pass it to model and test whether the model was able to give the top results, whether the model can give the results, the actual results in the top 10 or 20. Based on training and all of that, we will reduce the size of 20 to 10, 10 to 5 like that. And here 40 fields, top 40 will be reduced to 30, 20, 10 like that. But we require much more training. Now coming to this files vector store generation for table file, we need to pass this as documents. For each and every, we pass the tables, ERPNext tables file, and we also pass our trained model path. We have to use the latest version of the trained model, and then we provide this document. We provide page content table, and we pass the table name here with the prefix of table, and we provide metadata table and type table. Then we convert this docs into a files vector store by passing this embedding. Embedding is our model. This is how once we run it, we will generate our files vector store, and we can mention our files vector store would be saved to the specific directory we mentioned here. Then make sure when you are going to compare your models, I just mentioned before, you have to pass the model specific files vector store whenever you compare your models. Okay. Now I think you understood how what is this multi-retrieval structure, why we used that approach, because of the better accuracy and all other some other issues we solved from schema retrieval line. Yeah, because of the accuracy, and also many other small reasons are there, because multi-retrieval line still, as it's much longer than schema retrieval, but it can give better accuracy matters out of all. So that's why we used multi-retrieval approach. Now once we generated the tables via vector store, we can compare the old version and the latest version of the model by generating their respective via vector store, running that specific code. Now we already compared the model. This is how we compare the models, and this is how we train our models. This is how we generate the FIAS vector store. So I hope you understood the concept. And before winding up, I just wanted to show you a small test code where for an immediate test, if you wanted to check whether the model improved. We already do comparison of multi models, but if you wanted to make an immediate test, you can run a small code. I will show that. So you can do this code. You need to use Hugging Face embeddings, and you need to pass your model repo after pushing, or before pushing. You can check by passing the directory path here and by providing Hugging Face, but you need to make sure you have imported the Hugging Face library, otherwise you will get an error. And also make sure you already logged in Hugging Face. Then you can pass the path of your FIAS vector store. Here you can pass your tables FBS, table FBS you just generated now, and then you can view a list of questions as per your requirement. Then you can run this. Then you can check in the top 20. We provide k is equal to 20. In the top 20, whether the model have given the right tables or fields, like that. I hope you understood the technical video explanation of how you can improve your model, how you can train, how you can create training data, test data, how you can train your model, how you can test your model, how to compare the model, multi-models, how to generate your FIAS vector store, and how to why we used a multi-retrieval structure instead of a single retrieval structure, and how we can do a small immediate test case, how to push your model to Hugging Face, everything. Your own, how to create your own model repo on Hugging Face. I think I covered all these part, and I think I hope you all understood these areas. And if you have any issues, you can contact, or you can post issues on our GitHub, and you can contact at support@erpgulf.com. Thank you for watching this video. Bye.